How do we approach integrating cosine square root x dx? Well, I don't see anything like partial fractions jumping out at me. The first thing that comes to mind is to try substitution. The functions we have here are cosine and square root. So the first thing I want to do is try, say, w is the square root of x. Then dw is 1 over 2 square root x dx, or dx can be rewritten as 2w dw because that's a w. With that substitution, we now have cosine w times 2w dw. This can be done by integration by parts. That jumps out at me because I see two things being multiplied, and I look and see, can I integrate one of them and differentiate the other? And will it become simpler if I do that? Well, if I take the derivative of w, it goes away, so that would be simpler. So that's the motivation for integration by parts. Here's the generic formula. So if we say that the u is 2w, we want to take the derivative of it so it goes away. The dv is the rest of it, cosine w dw. Du would then equal 2 dw, and v would be sine of w. Plugging into this integral, we get u times v, 2w sine w, minus the integral of v sine w du, which is 2 dw. This can be integrated easily, so we have 2w sine w minus 2 cosine w becomes positive, plus a constant, because we've finished integrating, and now we substitute back 2 square root x sine square root x plus 2 cosine square root x plus c. There's the answer.